How much warning would we actually get before a city-killer asteroid hit? Not the movie version, where a telescope spots it years out and a crew of heroes gets launched in time. The real version, built from the actual capabilities of the systems watching the sky right now. Two numbers. The gap between them is the entire problem. Start with detection. A city killer in this conversation means something in the range of roughly 140 meters across, big enough to level a metropolitan area on impact, small enough to be genuinely hard to find. Objects that size don't glow. They don't announce themselves. They're dark rock, reflecting a small amount of sunlight, moving against a background of 100 billion stars. Current survey systems, like the Atlas network of telescopes, are built specifically to catch these before they arrive. For an undiscovered object around 140 meters wide, with an impact energy around 100 megatons, Atlas can provide as little as 3 weeks of warning. A 50-meter object, still capable of leveling a city center, might only be caught about a week out. 3 weeks. That's the detection side of the equation, for an object nobody has spotted yet. Now the response side. The only planetary defense method that has actually been tested, not modeled, not proposed, tested, is the kinetic impactor. Slam a spacecraft into the asteroid at high speed and nudge its orbit just enough to miss Earth. NASA's DART mission proved this works in September 2022, successfully shifting the orbit of the asteroid Dimorphos. But look at the timeline. DART took 5 years from mission start to impact, and that was a controlled test against a known, well-characterized target, with no crisis pressure and no need to build the spacecraft from scratch under emergency conditions. Planetary defense researchers are consistently clear that a real deflection campaign needs years to decades of lead time to reliably work. 3 weeks of detection, in the worst case, for an object nobody has found yet. Years to decades needed to actually do something about it. That's not a small shortfall. That is potentially the entire warning window, gone, before the response can even begin. To be clear about what this isn't, for a large asteroid that's already been found and catalogued, we typically get decades of warning, because its orbit is known and tracked. The 3-week number describes the genuinely dangerous case, a mid-sized object that has never been spotted before, approaching from a blind spot, like out of the sun's glare. That is the scenario where detection and response are on a collision course with each other, not just the asteroid. No figure in this video is invented. The 3-week and 5-year numbers both come from real systems and real missions. The gap between them isn't a guess. It's the honest shape of the problem.